Hey math kids, today we're going to talk about geometric sequences, and we are in chapter 5C, and we will start with example 7. Let's just jump right into it. We will definitely need this at some point, so I'm going to write this down. Just like for the arithmetic sequences, we needed a nth term formula, and this is the same version for a geometric sequence. Now, arithmetic was for adding and subtracting as we go through our sequence. Geometric is multiplying or dividing. And so let's just go through that. So consider the sequence 8, 4, 2, 1, 1/2. Show that it's geometric. So the way that we show this is geometric is we have to show that it's either addition or subtraction. So our common ratio this time, which is similar to the common difference in an arithmetic sequence, is we're dividing by 2, but we actually want to always write it as multiplication. So we are multiplying by 1/2 every time we go. Okay, so our common ratio is 1/2, and then we just have to state a starting point. So once we state those two pieces, we know that it's geometric, and that satisfies what it's asking on part A. Now part B, it says find the general term UN. So we're going to use this. So we're just going to say UN, then write down the first term, which is 8, plug in the common ratio, and then leave n minus 1, and that is essentially all we need. Now your book takes it a little bit further, so I'll just show you what they're doing. I don't think we need to take it past this, to be honest, but they think of 8 as a power of 2, so they think of it like that, and then they think of 1/2 as a power of 2, so they think of it like that. And then they use some exponent rules. So first we use this exponent rule where we multiply those two together. So we get 2 to the negative n plus 1. And then we still have 2 to the 3. And then we're supposed to add these exponents. And so we get 2 to the negative n plus 4, which we could reorder that to make it look a little bit nicer, and so they use that as their formula. This one's just as useful, but you'll have to do a little bit more simplification once you plug in numbers. This one you do the simplification before you plug in numbers, so whatever you prefer is fine. Once again, I would accept this in class. And then it says hence find the 12th term. So we can either plug in a 12 here, or we can plug in a 12 here. I'll plug it in here because I think most of you will prefer to use this one. Okay, so we do 12 minus 1, which is 11. And if we do 1/2 to the 11, that's the same as saying 1 to the 11 over 2 to the 11, and 1 to the 11 is just 1. I'm going to leave this as 2 to the 11 for a second, and then we still have 8. So if we multiply that over, we actually get 8 over 2 to the 11. If we think of 8 as 2 cubed, we can do that. Now 3 minus 11 is going to leave us with a 1 on top and an 8 on bottom. So we just need to figure out what 2 to the 8 is, and once we do that, we get 1 over 256. So feel free to use a calculator, but that's everything we need to do on that one. Now we're going to move on to example 8. And we get k minus 1, 2k, and 21 minus k. They're consecutive terms in a geometric sequence. Find k. So we're going to approach this very similar to how we did the problem that's like this with an arithmetic sequence. We know that the distance from here to here is we're multiplying by r, and the distance from here is we're multiplying by r. And so we can create a ratio. So we can say 2k over k minus 1 equals r, but we can also say that 21 minus k over 2k is equal to r. So since they're both equal to r, we can make them equal to each other. And so we have 2k over k minus 1 equals 21 minus k over 2k. We can cross multiply to get rid of the fraction. So we have 2k, 21 minus k, like that. And then we just continue to simplify. So multiply those together, we get 4k squared. This one we'll have to distribute, so we get 21k minus 21 minus k squared plus k. Alright, now we need to combine everything that we can. Since it's going to be quadratic, we need to get everything onto the same side. So I'm actually going to, well, I guess before I do that, let's combine those. So that's 22k. Okay, so 22k, I couldn't see if that was a minus or a plus sign. Minus 21 minus k squared, 4k squared. So we're going to add k squared. So we get 5k squared equals 22k minus 21. Then we need to move everything over here. So minus 22k plus 21 minus 22k plus 21. And so we end up with 5k squared minus 22k plus 21 equals 0. And then we can plug this into the quadratic formula, or we can try to factor it. So let's see. Let's try to factor it. So we're going to do 5 times 21. So 20 times 5 is 100. And then, so that's 105. So we have 105 is the number we're checking. 1 and 105. 2, 3. Let's see, does 3 work? 5, 6. So 3 works. What is 105 though? Okay, so it's 35. We know 5 works. That's 21. We still can't make this 22, so we gotta keep going. 5, 6, 7, 8, 9, 10, 11, 12, 13. I don't know what's going to work on this one. So let's see if the calculator's working yet. I'll reopen this. Pull this up. Use our friendly calculator. Okay. So let's do 105 divided by 7. Oh, there we go. 7 and 15. So that's actually the one we want. Those will work if they're both negative. So we do our box method. Put our first and our last in there. 5k squared, 21. And then break our x into 7x and 15x, both negative. Pull out the pieces we can. So this is going to be 5, these are k's actually. 5k, pull out 7, pull out k, pull out 3. Now, because we have a diagonal that's negative, that's a shortcut, and we actually know these will both be negative. So if we do 5k times k, we get positive k squared. 5k times negative 3 would be negative 15k. Negative 7 times k, negative 7k. Negative 7 times negative 3, positive 21. So that works out. Now we have our factored form. So we have 5k minus 7, k minus 3 equals 0. We can use the zero product property that says we can split those into 2 pieces, like that. Solve both of those for k. Divide by 5. So k equals 7/5. And this one we just add 3, and k equals 3. Alright, so those are the 2 values of k that make that true. So let's keep going. We'll move on to example 9.